This is UW-Madison engineering submission for the IAM3D challenge for the additive manufacturing. This drone was made using additive manufacturing with 3D printing at the UW-Madison Makerspace in Gwinnett Commons. The main goal is to carry a 1x1 block throughout a course, which was the main thing for IAM3D.
Here we have the electronics cover with the intricate W for Madison, and it's covering all our electronics and the frame. And over here we have the frame that I'm pointing to, the body of the drone. And as we look down here, we have the battery holder, which is also works as a holder for the payload arm. The payload arm has 4 magnets, as you can see, in order to collect the payload and carry on through the course.
This is the main control board for our drone. It controls basically everything. Underneath it is the ESC, which controls all of the motors. Over here, this blue board is our receiver. This receives communications from our transmitter, obviously, and this is where all of the inputs come in. The camera up front is hooked up to the main computer and then is sent through this board and this antenna back to our main headset. And these motors out here are the ones that drive everything and make the thing fly. The battery is on the bottom and is a 4-cell lithium polymer battery. And underneath that is the payload arm with 4 neodymium magnets for picking up the payload. Our propellers are 6-inch commercially bought plastic propellers. Currently we have our blue testing propellers on, but during competition we have some awesome red and black ones that match our school colors. Everything is held together using M2 and M3 bolts. And the construction is built to use as few of these parts as possible. We added these vertical stiffeners because one of the main problems we were having was actually the frame was too flexible. So these vertical ribs actually create a very, very rigid structure.
These stiffeners are an excellent example of our iterative manufacturing during the process of building this drone. We had many drones, such as the one that you can see here, where it snapped right along these stiffeners. And actually, before even this frame, we had a lot of other drone frames that ended up snapping right along here. Adding these stiffeners has decreased our number of drone frames that have snapped exponentially. One of the biggest outcome objectives of designing this drone was gaining a knowledge, understanding, and appreciation for 3D printing. During our time building the drone, we prototyped in both PLA and a carbon fiber fiberglass composite, learning versatility of materials that 3D printing is able to cover, as well as estimating the costs along the way. Being able to crash a drone frame and have a brand new one the next day is certainly a marvel of this modern day manufacturing method. Learning everything from infills to support structures to best practices when 3D modeling with the end goal of 3D printing in mind, this drone project has perfectly highlighted the benefits and some of the challenges that come with 3D rapid prototyping.